Example number 2 is probably more at level 2 level, and it's probably more likely to be the kind of thing you'd get in an end of year exam. And that is because the forces that are acting are not at right angles and are not acting at right angles to each other to start with, although we can do some tweaking to make that happen. So we've got 2 guys carrying a heavy sports bag by holding one handle each either side of the bag. So what we're kind of looking at is a bag, and the handles are going out like that, because when something's really heavy, it's much easier to carry it like that. So I'm going to draw my vectors now, and I'm going to draw a straight line to start with. And I've got one guy pulling out that way and one guy pulling that way. And the angle between the bag is 120 degrees. So that's there. You imagine the bag's down here, which makes that angle 60 and that angle 60 as well. And the reason I know it's symmetrical like that is that both of the guys are exerting a force of 200 newtons. So all the angles are going to be nice and even. Okay. Now your job is to find the resultant force. So to find a resultant force, we need to add these vectors together, and we need to add them head to tail. So what I'm going to do is I'm going to pretend to pick this arrow up and move it to there. So I'm going to redraw that again. Like that. So I've picked this arrow up and I've moved it here and got this. And I'm just going to draw my horizontal line in there. So this angle is still 60 and this angle here is still 60. Oh, I've made a mistake. I am so sorry. That is not 60. It's 60 divided by 2, so that makes that 30. Okay, so these ones here are both 30. Apologies for that. Okay, so when I add this one and this one, this is my resultant force. And actually it has to be equal to the weight force if we're going to pick that bag up off the ground. So that's your resultant force there. I've got a 200 Newton force here and a 200 Newton force there. Now what's happened by picking one of those vectors up and putting it nose to tail with the other one, I've created a right angled triangle there. In fact, it's an isosceles triangle as you see it there, and an isosceles triangle is made up of 2 right angled triangles. So what we're going to do is we're going to calculate the force for one triangle first. We'll just do it for one, and then if we double it, we're going to get the total resultant force. So we're just going to find this bit in here first. Okay, so find this first. So that's the opposite side. We've got the hypotenuse. In fact, what I'm actually going to do is redraw the triangle out here. So I've got 200. I've got 30 degrees here, and I want to find that's half the resultant force. Okay, so sine 30 is F resultant over hypotenuse, which is 200, or FR equals 200 sine 30. The reason I had to change it is because angles in a semicircle is 180. 200 sine 30 gives me 100 newtons. Okay, so the total resultant force is 100 plus 100, which is 200 newtons. Okay, so it's actually an equilateral triangle, but that is how you work it out, as you need to make a right angled triangle before you can solve that. Hope that helps. Thanks.